So next question is, what are collisions? Explain the possible types of collisions. Develop the theory of one-dimension elastic collisions. Collisions means this is a mutual interaction between two or more objects. When two objects are having some impulse between them, they collide between them, so that is called a collision. So there is, for small time interval, there is a large force applied, that's why it is called a impulse force. Impulse force is applied between the two bodies, then it is said to be a collision. The possible types of collisions, if we talk about, there are two types of collisions. One is elastic collision, another is inelastic collision. For elastic collision, momentum is conserved. Momentum is constant. Constant is nothing but conserved. So initial momentum is equals to final momentum, where momentum is a product of mass and velocity. Momentum is constant or conserved. Next, kinetic energy is conserved. That means initial kinetic energy must be equals to final kinetic energy. This will be conserved. For inelastic collision, momentum will be conserved. Momentum is conserved, that is initial momentum is equals to final momentum. Kinetic energy not conserved. So kinetic energy initial won't be equals to kinetic energy final. This will be greater than this one. There is a loss of energy. That loss transforms into either sound or spark or light, whatever it is. When two balls collides and if you hear some sound, that means there is a loss of energy that transforms into the form of sound. So our question is to explain one dimension elastic collision. One dimension means straight line motion. When two objects are taken in one dimension, that is called one dimension collision. For elastic, we need to elastic 1D, we need to solve this. So let us assume two objects m1 and m2. Initial velocities are u1 and u2. They have collided each other. After the collision, their masses won't be changing, but the velocities will be changing, v1 and v2. u1, u2 are initial, v1, v2 are the final velocities. As we have seen for elastic collision, momentum initial equals to momentum final because momentum is conserved. Initial momentum is mass into velocity of initial m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Take m1 one side, I take m1 u1 as it is. This m1 I will take in the left side, m1 v1. Right side m2 v2 and this m2 will be taken right side, m2 u2. Take m1 as a common, u1 minus v1 and m2 as a common, v2 minus u2. This is equation 1. And the next, what is conserved in the elastic collision is kinetic energy is conserved. Initial kinetic energy of this object is half m1 u1 square and for this is half m2 u2 square. Sum both them equals to remaining of these two. So half m1 u1 square plus half m2 u2 square is equals to half m1 v1 square plus half m2 v2 square. Cut all the half, left side and right side, and take m1 together, m1 u1 square minus m1 v1 square is equals to m2 v2 square minus m2 u2 square. Take m1 as a common, u1 square minus v1 square is equals to m2 as a common here, v2 square minus u2 square. And we know a square minus b square formula, that is a minus b into a plus b. That will write this equation as u1 minus v1 into u1 plus v1 is equals to m2 into v2 minus u2 into v2 plus u2. This is equation 2. So we got two equations, first and second equations. We'll divide this to get some relation between the velocities. Second equation is m1 u1 minus v1 u1 plus v1 is equals to m2 v2 minus u2 into v2 plus u2, and a division of this will be first equation m1 u1 minus v1 m2 v2 minus u2, m1 u1 minus v1 and m2 v2 minus u2. You can cancel this and this here also. Finally we got u1 plus v1 equals to v2 plus u2. This is equation number 3. We'll take it off from here v2 value, u1 plus v1 minus u2. Similarly we'll take it v1 value, v2 plus u2 minus u1. This is equation 4 and this is equation 5. Substituting equation v2 in first, then you will get v1 we get. If you substitute v2 in equation 1, we get v1. Substitute v1 in equation 1, then you get v2 we get. So what is the first equation? First equation is this, m1 u1 minus v1 is equals to m2 v2 minus u2. We'll substitute in this equation. What is the first equation? m1 u1 minus v1 m2 v2 minus u2. We need to substitute v2 value, so that you will get the final velocity after the collision for one dimension elastic collision. So what is v2? m2, v2 value is u1 plus v1 minus u2, and this is one more u2 is there, minus u2, and we'll write this as a m2 u1 plus v1 minus 2 u2. This is m1 u1 minus v1. Multiply this, m1 u1 minus m1 v1 is equals to m2 u1 plus m2 v1 minus 2m2 u2. We need v1 values, so take together v1 values. One side, remaining part is left hand side. So m1 u1 minus m2 u1 plus 2m2 u2 is equals to m1 v1 plus m2 v1. This m1 v1 has come, right side becomes positive. Take v1 as a common, m1 plus m2, and this one you take it as a u1 common, m1 minus m2 into u1 plus 2m2 u2. v1 we need, take this as a denominator. So m1 minus m2 into u1 plus 2m2 u2 divided by m1 plus m2, and this is a velocity v1. This is the final velocity of the first object after the collision in one dimension elastic. So this we need to calculate. Similarly, if we substitute v1 in equation 1, we'll get v2 value. You can substitute this, take it as assignment and try. You will get final answer m2 into m1 into u2 plus 2m1 u1 by m1 plus m2. That's it.